Welcome back, Mindsetters. I hope you had a nice little break. I hope you guys went and grabbed yourself some snacks, something warm, a blanket. I know I've been saying that a lot, but make sure you're warm, because winter is super cold. And guys, I don't want you to forget that today is June 16th, Youth Day. Enjoy it, treasure it, learn about it. Make sure you look it up. Ask your parents. I know they don't look like youth, but they knew about it. So make sure you learn more about it. And guys, I'm loving what you're doing on the page, so keep posting. But for now, I'm going to hand over to John. John, take it away.
Ty, thank you so much. Guys, we're doing that rice table. Now, I want to take it slowly, but we want to get this right. If you've got questions about this, please post them on the page. After the show, I'll be online and I'll take any of your questions about this particular example. Please make sure that you're getting it right. We'll take it slowly and we'll make sure that we'll get this one sorted. Okay, so we've got our given information. We know the number of moles and we've sorted it all out, got the right units, and we've got a mark already over here because we've written down the KC expression. So that's a mark in the bag. The next thing is to write down the balanced equation. Now, the ratio of the moles is given from the balanced equation. They've given you the balanced equation in the question, and we know that we've got 1 mole of nitrogen, 3 moles of hydrogen, and 2 moles of ammonia. Now, from the question as well, we know what the initial things were. We know that we had 2 moles of hydrogen and 1,5 moles, so we fill that in. 2 moles of nitrogen, just make sure, of 2 moles of hydrogen. 2 moles of hydrogen and 1,5 moles of nitrogen. So what does that mean? I've got the reactants. If I've only got that stuff and that's injected, have I got any product? No. Remember, these are your reactants. This is your product. And we can say, I've got 0 over there. So put the 0 in. I think it helps. Now we go to the next part of the equation, and it tells us that at the end of the reaction, when it reaches chemical equilibrium, I've got 1 mole. So now I want to explain. Ratio, initial, then it says change. What has changed? I skipped that row, and that's why we say it's rice. Okay, R for ratio, I for initial or start, C for change, and E for equilibrium. And I've put another E because I want equilibrium in moles and then equilibrium in concentration. So I was told I've got 1 of those at the end, at chemical equilibrium. So that's the given information. I've recorded the given information into my table, and there it's sitting like that. Now I've got to do some manipulation. I've got to start doing some working out. Now, here's something that I find very useful. Anything that is produced, anything that is on the other side of this double arrow here, okay? Anything on the other side of the arrow, of the reaction coordinates, I'm going to make this positive. I'm going to say I'm adding to it. When I make something, I'm going to make sure it's plus. What I'm going to do now is I'm going to say, if I started with this and I got to that, so I started with 0 and I get to 1. What happened? What was the change? Well, the change is I've got plus 1. So 0 plus 1 gives me 1. These 2 lines I must add together to give me the answer here. So 0 plus 1 gives me 1. Now, here's it's not tricky, but you just need to know it. We want to find out what the change is over here and here. How are we going to work it out? Well, the good news, guys, is I've labeled them in green. I put ratio and change in the same color. And what that's telling me is that whatever answers I get in this line, they must be in the same ratio as that line. So now this becomes a really basic calculation. Now, I know that not all of us do Maths Lit, but the Maths Lit guys are brilliant at ratio. If you're struggling and you do core maths, you might have forgotten about some of the ratio calculations. Go and ask a buddy who does Maths Lit. They'll tell you all about ratio. So, but here's my way of doing ratio. I reckon that I've got 2 parts here, and I've only got 1 part here. I want to get 2 is to 1. I'm saying 2 to 1. What did I do to the 2 to get 1? I divided by 2. Easy? So what must I do to the stuff that I've got over here to get to 1? Look over here. This is the ratio here. This is 1 part. I want it to be in the same ratio. 1 is to 2. So between this one and this one, there must be a ratio. So 1 is to 2. It must be in that ratio. What am I going to do to the 1 to get the equivalent ratio here? I must divide by 2. So what am I going to do? I'm going to say 1 divided by 2 is equal to a half, 0.5. Notice, if I doubled this, I would get 1. If I double that, I get 2. But remember the other thing that I said. I said on this side, I'm going to do a plus. On this side, I'm going to do a minus. So I'm going to make sure that that's minus 0.5. So I've now got the 1. If I found the 1 of the ratio, then it's easy to find the 3 parts. I need this to be a 1 is to 3 ratio. I need this to be a 1 is to 3. So if this is 1 is a half, then what is 3 going to be? 3 times a half? 1.5. I hope you got that. 1.5. We put a minus over there. Now, just double check yourself. Let's multiply this row through by 2. Minus 0.5 by 2 gives us 1. Minus 1.5 by 2 gives us 3. 1 by 2 gives us 2. It's in the same ratio. You can check it. Make sure you got the ratio sorted. Now the next part is easy. Remember what I said over here? We're just going to add these 2 rows. We're going to forget about the ratio line now, and we're just going to do with the initial and the change. We're adding those 2 together. 0 plus 1 gives us 1. Now, what are we going to do when we get 2 and minus 1.5? Oh, guys, that's not difficult. A half. 1.5 minus a half, 1. Those are the moles that we've got. What about our concentration? Well, remember, we said it earlier. Concentration is the number of moles divided by volume, and we've got a volume of a half. So what we must do to each of those, we must divide by a half. Now, here's something that I know that does work on the calculator, and you can put it in, and that's fine if you're comfortable with that. But if you divide by half, it's the same as multiplying by 2. So it's easy. Multiply 1 by 2 gives you 2. Multiply a half by 2 is 1. Multiply 1 by 2 gives you 2. Those are your concentration values. Where are you going to substitute those in? You're going to substitute those in back into this equation over here. You're going to substitute it back into your equilibrium expression so that you can write down your final, just undo that, you can write down your final answer. So I'm going to just do my working over here. You can obviously rewrite this. I just haven't got time to do that, and do the substitutions. So let's make sure we've got it. 2 is the ammonia. So I'm going to substitute into 2. I'm going to put 2 where I see the concentration of ammonia and square it. What was the concentration of hydrogen? Look, under the hydrogen line, all the way down, concentration is 1. So I must put the concentration of hydrogen 1 cubit multiplied by my concentration of nitrogen. The end, my concentration of nitrogen was 2, and I substitute that in. And I don't have to square it or do anything. What do I get? I get 4 over 2, which is going to give me an answer of 2. Remember, KC has no units. It's just that answer. Okay, guys, that's about it. Remember, we're back next week with revision, term 2 revision, but Ty, life science is up next.
Yes, exactly. So guys, make sure you stay tuned. Do not go anywhere, because we've got another exciting session of life science coming up. So guys, make sure you enjoy your June 16th. And guys, for me, I'm going to sign off and say, see you next time.